Okay, so I am Manu, pursuing PhD from University of Hyderabad. So last class we discussed some bioinorganic questions, and in this class also we will be discussing some questions related to bioinorganic chemistry. And I'll start sharing the screen. So now we are going to learn about bioinorganic chemistry. So last class we learned about hemoglobin and myoglobin and also hemocyanin. This hemoglobin and myoglobin has porphyrin ring system. Hemoglobin is 4 oxygen molecule carrying and it is oxygen transport is its function. Myoglobin's function is oxygen storage and it stores 1 oxygen per myoglobin, and the molecular weight is 16,500 for myoglobin and 64,500 for hemoglobin. And myoglobin is having a single helical chain and the helical chain is having 153 amino acid, whereas hemoglobin is alpha 2 beta 2 and has 141 and 146 amino acid. So this is about hemoglobin and myoglobin. Okay. And we also learned in last class that each hemoglobin and myoglobin has a deoxy as well as oxy state. Okay. So in deoxy state, both myoglobin and hemoglobin has a deoxy and well as oxy state. So in deoxy state, it exists in Fe2 plus and in hemoglobin, it exists in Fe3 plus. In this case, it exists in both case Fe2 plus. In deoxy, it will be high spin and oxy, it will be low spin. So this is D6. So anyway, it will be it is high spin and will be paramagnetic. Same goes with here also deoxy Fe2 plus D6 high spin paramagnetic. Whereas in oxy case, this is Fe3 plus D5. So we expect it to be paramagnetic even though it is low spin because of one unpaired electrode. But due to antiferromagnetic coupling, it will be diamagnetic. And here also oxy state is diamagnetic. So both oxy states are diamagnetic and deoxy state are paramagnetic. And the oxygen molecule is attached in both hemoglobin and myoglobin as superoxide, O2 minus. And we also learned about cooperativity, Bohr's effect. Bohr's effect means with decrease in pH, the binding towards oxygen by hemoglobin also decreases, whereas myoglobin is pH independent. And we also learned about effect of partial pressure of oxygen. As partial pressure of oxygen increases, binding efficiency of both hemoglobin and myoglobin increases. This is all what we learned about hemoglobin and myoglobin in last class. We also learned about hemocyanin. So hemocyanin don't have heme group, does not have even cyanide group. It has copper used for oxygen transport and blue blood. It is called as blue blood. Okay. So in the oxy state, that is diamagnetic because Cu will be in +1 oxidation state D10, and in oxy hemocyanin Cu2 plus D9, but still it will be diamagnetic due to antiferromagnetic coupling. So in this case, it was O2 minus superoxide, but as in case of hemocyanin, it will be O2 2 minus peroxide. Okay. So these all things we learned in last class. Now in this class, we will be learning about amino acids. There are 20 amino acids in our body. We will be learning about that. Heme, erythrin, chlorophyll, plastocyanin, and azurin. Okay. Now, the first question is from 2013 GATE chemistry paper, question number 18. The correct sequence of the amino acid presence in the tripeptide given below is. So we have 3 amino acid here, and each amino acid is represented by its first 3 letters / and the second amino acid, like that. So we have to find out which are the amino acids, and only if we know the structure of amino acid, we will come to know that what are the amino acids present in the tripeptide given. So an amino acid, what is an amino acid? Amino acid has an acid carboxyl functional group COOH and amine functional group NH2 and a hydrogen and an R group. Okay, and based on this R group, we get different amino acid. The other 3 parts, that is hydrogen, COOH and NH2 are same in all amino acids. So we only need to know the R group, and based on R group, we can find out which is the amino acid. Okay. Now, amino acids are classified into 3. Essential amino acid, non-essential amino acids, and conditional amino acid. So essential amino acids are those which cannot be made by the body and hence they must come from food. So there are 9 essential amino acid which has been listed here: histidine, isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan, and valine. We will learn about each amino acid, the structure of each amino acid. Only that much is required for answering such kind of questions. And I have seen such kind of questions being asked in other competitive exams also. So don't worry, even though 20 amino acids are there, many of the structure is very easy and we can learn very easily. And the second category is called as non-essential amino acid. So non-essential meaning human body itself can produce such amino acid and there is no requirement that we have to get it from food. Okay, so there are 11 non-essential amino acid. And conditional amino acids are those which are normally not essential, but in certain circumstances like illness, stress, etc., it might become essential. And the amino acid's name has been given. Now, we will learn about the structure of amino acid. So this might seem complicated, but we can learn easily because all the 3 groups are same. For example, first let us take glycine, COH, NH2 and hydrogen. This much is same. This much is same for everything. And for glycine, one H extra, one H will come. Alanine, one CH3 will come. So these 2 amino acids are very easy. Glycine, hydrogen, alanine, CH3. Now valine, you just think of it as V. Just we have CH and just one V. So one V meaning what? Here it is CH3, here it is CH3 and here CH will come. So valine means one V you can draw. So you will get the structure of valine. So in valine, after valine, leucine comes. So in valine you have 3 carbon and in leucine it will become 4 carbon atom you will have. And if you know the structure of leucine, the structure of isoleucine become easy. So leucine, after valine, leucine comes. So you can do like this amino acid you have. This is the structure of valine. This AA I am representing as carbon, COOH, NH2 and H. This is AA. Okay. So in case of valine, what we are getting? One V. So in case of leucine, one carbon will come in between and you have to fill up the valency. Then you will get the structure of leucine. So if you know leucine, just the isomer of that will be isoleucine. So you will get the structure of isoleucine also. Now, we already came to know 5 amino acid structure. So like this, we can learn all the structure. For example, phenylalanine. If we know alanine, we have to just add a phenyl group to alanine and we will get phenylalanine. So these are easy amino acid structures. And cysteine and methionine have sulfur group. Okay, cysteine, methionine have sulfur group. This can be asked in some questions like what are the interactions present, and in amino acid containing sulfur there can be disulfide linkages and also that also is an interaction. So questions can be asked like that. So cysteine meaning this much part is same, CH2SH. Serine will become CH2OH. Cysteine, CH2SH. Serine, CH2OH. So if you know cysteine, you can easily get serine, right? And threonine, one more CH3 will come like that. And for example, if you know asparagine and glutamine, you will know aspartic acid and glutamic acid because this much is anyway same. CH2 C double bond O NH2 is asparagine. When it becomes aspartic acid, this NH2 will become OH. Similarly, if you know asparagine, glutamine, you can get just add one more CH2 in between and you will get glutamine. And if you know glutamine, this NH2 you can replace with OH and you will get glutamic acid. So like this, you can now itself, I think you will know like 10, 12 structures if we know this much. And the other structures are also quite easy. Just you will take some time, but still if you know such structures, it might help in answering such question and without even any effort, you will get the marks very easily. There is no chance of making any mistakes in such cases. So it's important to know the structure of these amino acids. Okay. Now So in question, a tripeptide is given. Tripeptide meaning 3 amino acid is present in the question, is given in the question. So how two amino acid combine? Two amino acid combine through a peptide bond, and it is shown red here. C double bond O NH. This is called a peptide bond. What will happen when two amino acid come together? One OH from here and one hydrogen from here will combine, and we will have an elimination of water molecule, and this carbonyl group and this NH will combine, and the bond formed is called as peptide. So in order to understand which are the amino acids present in the tripeptide given, we should know where is the peptide bond first. We should identify the peptide bond, break it, and then we will get the individual amino acid. So where is the peptide bond? Wherever C double bond O is bonded with NH. So this is the structure given in the question. So we have two peptide bond, C double bond O NH here and here. So if we break the peptide bond, we will get 3 different amino acid. And after breaking, what we have to do? While forming, one OH is gone from COOH and one H is gone from NH. So we have to add that in order to get the individual amino acid. So we will add OH to carbonyl, H to hydrogen, NH. Similarly, here O carbonyl is there, we are adding OH. And in this case, NH is there, so we will add a hydrogen. Now we got individual amino acid. First step is over. When we get individual amino acid, now the next important thing is to know the name. So we know this much is represented by AA. It is same for everything. We don't have to look at that at all. So the remaining R group. So we saw remaining R group is, see, the structure is like V. V for valine. Okay, like that you can remember. So you got the first amino acid easily, valine. What is second amino acid? Second amino acid has a CH2OH. We saw CH2SH and CH2OH. CH2SH was cysteine and CH2OH was serine. So second is serine. And the third one is CH2CH3OH. That is threonine. Two amino acid having OH we saw, that is serine and threonine. So the first one is serine and second one is threonine. Even though it is difficult for you, even if you know the first two, you will get the answer. If you look into the option, you can identify that. For example, first one we understood valine, second one serine. There is no other option, only option A is there. And the third one is threonine, so it is represented by THR. Therefore, the correct option is option A. And for further reference, you can visit to the lecture amino acid, and the YouTube link is given here. Okay, so this is regarding the amino acid. These amino acids will come in coming class, means coming questions also, because many proteins and all will be attached, like many things will be attached with the glutamic acid, aspartic acid and all. So if we know the structure, it will be easy for us to imagine. Okay, so you can take screenshot of the amino acids present. I will show you. This amino acid you can take screenshot, otherwise it is available in Google also, but still you can take screenshot and then it will be easy for you to learn. Okay, if it is clear, then we can move to the next question. If you have any doubt, you can ask to me. Okay, stop me in between. Okay. Next question is regarding heme erythrin. So last class we learned about hemoglobin, myoglobin and hemocyanin. So this class we will be learning about heme erythrin. Heme erythrin. Okay. During oxygen transport by heme erythrin, oxygen is bound as. So in last class, hemoglobin, myoglobin, oxygen was bound as superoxide. Hemocyanin, oxygen was bound as peroxide. And now we are going to learn about heme erythrin, how oxygen is bonded to it. Now we will learn all about heme erythrin. Hemerythrin is also a non-heme protein. So questions can be asked among the following, which are heme protein, and options can be hemoglobin, myoglobin, hemocyanin, hemerythrin, etc. So by saying the word heme, you should not pick it. Hemerythrin and hemocyanin, both of it does not have a heme group. Only hemoglobin and myoglobin have heme group. Okay. So now hemerythrin. Hemerythrin is a non-heme protein. It is also involved in transportation of oxygen molecule in invertebrate, like mollusca, arthropoda are examples of such phylums. And this hemerythrin exists as octamer composed of alpha and beta type subunit. We learned about what is alpha and beta when we learned about the structure of protein. The secondary structure of protein can be of two types, alpha helix and beta pleated, right? We learned that in previous classes. So this hemerythrin mostly exists as octamer. And this is the structure of hemerythrin. Okay. So what all questions can be asked from this portion? We will cover all. Okay. So we have two states, deoxy state as well as oxygenated state, right? And this is deoxy state, this is oxy state. Oxyhemerythrin, deoxyhemerythrin. If we see the oxidation state of iron, in deoxyhemerythrin, both iron exist in Fe2 plus oxidation state. So it can be asked how many iron centers are present per hemerythrin. So per hemerythrin, we have 2 iron centers. And in deoxy state, iron exists in Fe2 plus oxidation state, whereas in oxyhemerythrin, iron exists as Fe3 plus oxidation state. Okay, first point. Second point, to which all this, how the two iron atoms are linked together. It is linked together with an aspartic acid group. This R is aspartic acid, one is aspartic acid, one is glutamic acid. Okay, so aspartic acid we have, glutamic acid we have. CH2COOH, CH2CH2COOH, one COOH group is there. The structure before we learn no amino acid structure that comes into picture. Even if you don't know the structure, you should know. It is better you know the structure, but at least you should know that this is connected to through aspartic acid, glutamic acid, and one OH group. Okay. Now, next question can be asked is that what are the coordination of iron centers? So, iron centers are connected to histidine. Histidine through nitrogen atom present in histidine. And coordination numbers, we have 2 iron centers. In deoxy state, one iron center is hexacoordinated. 1, 2, 3, 4, 5, 6 hexacoordinated. Whereas the second iron center is 1, 2, 3, 4, 5 pentacoordinated. This can be asked as a question. What are the coordinations of iron centers present? So one iron is hexacoordinated and the other center is pentacoordinated in deoxy state. Whereas in oxy state, both are hexacoordinated. So this can be asked. Please keep this in, please remember this. And now about regarding the magnetic. Both are diamagnetic, ES are inactive, and this is colorless, and this becomes due to ligand to metal charge transfer. It is red violet in color. And one important thing is that here we can see HO2 minus is present, HO2. Due to there will be hydrogen bonding with this hydrogen and this will exist as HO2 minus. So if they ask like hydrogen bonding is present in which molecule, hemoglobin, myoglobin, hemocyanin, only in hemerythrin there is an hydrogen bonding. In other case it exists as superoxide or peroxide. And in this particular case, it exists as HO2 minus. HO2 minus. Okay. And it is coordinated to only one ion center. It has no coordination with this, only with this ion center. So what was the question? How the oxygen exists? It exists as HO2 minus and it is connected only to one ion. Ion in which oxidation state? In oxyhemerythrin, ion will be in +3 oxidation state. So in hemerythrin, oxygen transport, oxygen is bound as HO2 minus and only to one Fe, which is present in +3 oxidation state. Okay. Now, we learned about hemerythrin. Okay, these are some important molecules. Hemoglobin, myoglobin, hemocyanin, and hemerythrin are some important molecules, and we should know all the basic things that are related to this. The number of oxygen, this is another question that was asked related to hemerythrin in 2013 GATE chemistry, question number 16. The number of oxygen molecules that a molecule of hemerythrin can transport. It is clear from the image, one hemerythrin is attached to one molecule of oxygen through one Fe3 atom. So, the number of oxygen molecules that a molecule of hemerythrin can transport is 1. So, it is very easy. Just we have to give 1 and you will get marks very easily. And the next thing is regarding photosynthesis or chlorophylls. The metal ion and macrocyclic skeleton present in the green pigment of plants respectively are. So we have 2-3 option: Mg2 chlorine, Mg2 chlorine, Mn2 chlorine, Mg2 porphyrin. What here we have learned about chlorine ring system. Chlorine ring system was present in case of cobalt. Whenever cobalt is present, cyanocobalamin, adenosylcobalamin, and methylcobalamin. In that cobalamins, chlorine was the ring system present. And in hemoglobin, myoglobin, porphyrin was the ring system present. And now in chlorophyll, the green pigment is chlorophyll. We will learn about chlorophyll. What are the pigments? What is the ring system present in?
Hello, ma'am.
Hello.
Ma'am, I have a doubt from hemerythrin.
Okay.
Ma'am, you told that hemerythrin exists as octamer. So,
Yeah.
So there will be iron compound of 8, ma'am. I mean 8 iron complexes are there.
Actually, it exists as octamer, but one hemerythrin, meaning the structure I have shown, no, that is one hemerythrin. That one hemerythrin, how many molecules it carry? That is the question. So, one hemerythrin carries only one oxygen molecule. It might exist as octamer 8, or it in some cases it exists as tetramer, monomer. That is just its existence. But how many molecules one hemerythrin carry is according to the structure. You have seen the structure, no, which I have shown. This structure you should remember, and you will get all the answers from this structure. One hemerythrin is the structure given here. So one hemerythrin, how many oxygen molecule will carry is 1. Is it
Yes, ma'am.
okay?
Yes, ma'am. Thank you.
Okay. Okay. So now we will move on to learning about chlorophyll. So we know what is photosynthesis. Everybody know the earth surface, whatever energy is coming, only 1% of that energy is converted into chemical energy by photosynthesis. Okay. So the main pigment that is present in photosynthesis is called as chlorophyll, which act as photosensitizer or the main pigment present in photosynthesis. And there are chlorophylls, can be chlorophyll A, chlorophyll B, etc. So the ring system of chlorophyll is called as chlorine. You can learn like this: chlorophyll, chloro, it will be chlorine. When cobalt was present, CO, the ring system was chlorine. Okay, and hemoglobin or myoglobin ring system is porphyrin, CO, CO, chlorine, chloro, chlorine. Like that you can learn. Okay. Now the ring system is chlorine. And what happens to chlorine system? It looks like porphyrin system, right? What happens is that in porphyrin ring, if you remember, there we had 11 double bonds. But in this case, one double bond is reduced and we will have only 10 double bonds. So it is like a reduced, one double bond is reduced from porphyrin ring, and then we will get chlorine ring system. It is green in color and present inside chloroplast. And we have to know the central atom. What is the central atom present? It is magnesium 2 plus in case of chlorophyll. Okay. Now I told you chlorophyll can be either chlorophyll A or chlorophyll B. Chlorophyll A is the main photosynthetic pigment and it is involved in light reactions. We will learn what is light reaction, what is dark reaction. So first of all, let us only know that chlorophyll is present inside chloroplast of plants, which will help in photosynthesis. The central atom being Mg in +2 oxidation state. The ring system is called as chlorine ring system. The chlorine ring system is nothing but one double bond is reduced from porphyrin ring system, and we can have chlorophyll A, which is main photosynthetic pigment, which is involved in light reactions, whereas chlorophyll B, xanthophylls, carotenoids, etc., are called as accessory pigments, because this will not take part directly in light reactions, but this will absorb light and will pass that energy to chlorophyll A. So that's why these kind of pigments, chlorophyll B, xanthophylls, carotenoids, etc., are called as the accessory pigments. Now, what happens in photosynthesis? The basically overall chemical reaction of photosynthesis we can write like this. What will happen? There is a combination of water and carbon dioxide. In the presence of chlorophyll, this will convert into a carbohydrate, and oxygen is also formed. So water is getting converted to oxygen and carbon dioxide is getting converted to a carbohydrate. Okay, this is basically what is happening in photosynthesis. Now we can convert, we can say that photosynthesis is having two parts: one light reaction and one in dark reaction. So light reaction meaning, as the name suggests, there will be an absorption of light and ATP, NADPH, etc. will be formed. So there is the main thing happen. Water splitting happens and oxygen formation happens here. And it occurs at the grana. Grana meaning we have chloroplast, right? Inside chloroplast, there is folded like sac, disc-shaped sac kind of thing, which is called as thylakoid. And each sac present in thylakoid is called as grana of chloroplast. So question can be asked, light reaction, where it takes place? Grana of chloroplast, because dark reaction takes place in stroma of chloroplast. So in between the grana, there will be a empty space where gel-like material will be filled, which is referred to as stroma. Okay. So light reactions takes place in grana and dark reactions takes place in stroma. So light reaction meaning there will be absorption of light, and dark reaction there is no need of light. Here in light reaction, ATP, NADPH, which are energy molecules, that will be formed, whereas the ATP, NADPH, etc., which are formed in light reactions, are utilized in dark reactions. Okay. And in light reaction, oxygen formation takes place, and in dark reaction, carbon dioxide is converted into carbohydrates through Calvin cycle, and the cycle is called as Calvin cycle. Okay, so this is a representation. So in light, what will happen? The water will be converted to oxygen. So 12 water molecule will be converted to 6 oxygen. Along with that, NADPH and 18 ATP will be formed. This happens in the dark side. Okay, and in the light side, and in the dark side, carbon dioxide will be converted into C6H12O6 is an example, but carbon dioxide is converted to basically to carbohydrates. Okay, now I will tell you about photosystem. Photosystems are photosystem 2 and photosystem 1. Two photosystems are present in during photosynthesis. Okay, so what will happen is that we will have a photosystem 2. First, don't go by the name 1, 2. First, actually, photosystem 2 P680 will absorb light. Okay, and from the ground state, this will come to the excited state. Excited state, let me represent by a star. Okay, so now P680 becomes P680 star in an excited state. In excited state, this is a pigment 680. It absorbs the energy of 680 nanometer, and hence it is called as P680. If some question asked which photosystem has absorb high energy photon and all, we have photosystem 1. It is P700. It absorbs 700 nanometer wavelength. Photosystem 2 has P680. It absorbs 680 nanometer wavelength. So wavelength is less, meaning energy is more. So that's why this is high. He said it absorbs high energy photon, whereas it absorbs low energy photon. Okay. Now, in what is happening is that P60 energy comes, P60 in ground state will come into excited state. Okay. In excited state, this pigment acts as reducing agent. Reducing agent meaning it will give electron. Okay. It will donate electron to what? First, it will go through pheophytin. Pheophytin. You should know the name through what these electrons are transferring, so that if question asked from where P60 is giving electron to which uh, molecule, pheophytin is the name, and pheophytin will give to plastoquinone. Plastoquinone. Okay, these are quinones. There are, if I have to explain each, that will take so much time. I will explain 2-3 things from here. This will give to risky, and then it will give to cytochrome BF complex. Okay. Then this will give to plastocyanin. We will learn about plastocyanin in this lecture. Plastocyanin and acerine, which are blue copper proteins. I think whoever is teaching you about paradoxine and all, they will teach you each one separately. I will be teaching about plastocyanin, and from plastocyanin it will go to photosystem 1. Okay, so I will right here, photosystem 1 is P700. So first, who is absorbing? P680. Photosystem 2 is absorbing. It is coming to excited state, which will act as reducing agent, hence giving electron to pheophytin, then to plastoquinone, risky, cytochrome BF complex, plastocyanin. So one question I have seen that from which complex P700, that is photosystem 1, gets electron? It is from plastocyanin. Now, this will again absorb energy and will go to P700 excited state, and then this will give to ferredoxin. Ferredoxin means Fe2S2. Okay, it will give to ferredoxin, and from here what will happen? NADP plus will be present, will be converted to NADPH. So we are getting NADPH. This is the last of light reactions. So transferring electrons from photosystem 2 to photosystem 1, finally we are getting energy molecules NADPH. We got NADPH. This much is light reactions, photosystem 2 and photosystem 1. And in dark reaction, this NADPH and all will be used, which will convert back to NADP plus after using of electron, and this will happen. CO2 will convert to carbohydrate. Okay, so these are the this is the photo system. And one more thing is that P60 is in excited state now. Okay, now after giving electron, this will come back to ground state, but then it will be P60 plus, because it has given one electron, so it will be P60 plus. So it has to again come back to P60, right? It need one electron. From where it will take electron? From water it will take electron. Water will be converting to 4H plus O2 plus 4 electron. These electron it will take, and this will come back to P60. So in this state, this acts as an oxidizing agent, whereas in this state it acts as a reducing agent. Okay, this is the thing that is happening in photosynthesis. And so these are the basics: light reaction, dark reaction, photosystem 2, photosystem 1. What happens in light reaction? Oxygen formation. Dark reaction, carbohydrate formation. Light reaction occurs in grana of chloroplast. Dark reaction happens in stroma of chloroplast. In light reaction, energy molecules are formed, whereas in dark reaction, these energy molecules are utilized to form carbohydrate. Right, this is what is happening. And you can learn about Calvin cycle also. Calvin cycle, I hope somebody will be teaching you while dealing with that. Maybe next class I'll be teaching, or somebody else will be teaching you. It is easy. It will go through some step where ribulose diphosphate will convert to 3-phosphoglycerate and all. So I don't know whether I haven't seen any question related to that. If I come across Calvin cycle question related to that, we will be learning about that also. So now, whatever questions I have come across regarding photosynthesis, I have explained through this mechanism. I hope this helps to answer the question. So this question is pretty easy. We need not want to know any of these things. From the first slide itself, this is pretty simple. We should know the central metal atom and the ring system. But I just explained a little bit extra so that if a question comes in future regarding any of photosynthesis, you will be able to answer. So the question was, the metal ion and the macrocyclic skeleton present in the green pigments of plants respectively are. In green pigment means chlorophyll. So the metal ion, we have seen magnesium, which is present in +2 oxidation state, and the macrocyclic skeleton present is chlorine ring system. Okay, this is the answer for this question. So I have given some reference here. This book is actually I used to refer when I was in degree class. So I find it helpful. So I just wrote here. Now, okay, plastocyanic. So in last, when we wrote about this system, photosystems, we learned that plastocyanin comes, which will give electron to the photosystem 1 P700. So there is a question related to plastocyanin, which is a blue copper protein. So they have asked the coordination geometries around the copper ion of plastocyanin in oxidized and reduced form respectively are. And some geometries are given to us. So we will learn a little bit about plastocyanin, blue copper protein, and we will also learn a little bit about azurin and another blue copper protein which is related to this, so that if any question asked next time regarding azurin, you will be able to answer that question also. So in question itself, it is given plastocyanin is a blue copper protein, meaning blue in color, and copper is the central metal atom. It is not like hemocyanin, where the name is hemocyanin and it does not have heme or does not have cyanide. This blue copper protein is blue in color and contains copper as the central metal atom. There is no confusion. And this blue copper protein mediates electron transfer that we saw earlier in photosynthesis. This plastocyanin is useful. It mediates electron transfer from photosystem 2 to photosystem 1. That is the mediator. This acts as a mediator. The cytochrome BF complex from photosystem 2 to P700 from photosystem 1 to photosystem 1. Okay, this we learned last time. And this is the first blue copper protein characterized by X-ray crystallography. So if a question asks, mostly it won't ask, but still for your knowledge, I am telling this is the first blue copper protein that has been characterized. And now, obviously, this plastocyanin is an electron mediator, electron transfer mediating agent. So it will have an oxidized state as well as a reduced state, right? So in oxidized state, copper, the central atom copper will be present in copper 2, and reduced state it will be present in copper 1. So copper 2 meaning the electronic configuration is D9, copper 1 D10, right? D9 meaning it has one unpaired electron, it will be paramagnetic and ESR active. This will have blue color due to ligand to metal charge transfer. Whereas the reduced form is D10 completely paired, so diamagnetic, ESR inactive and completely colorless. So, and the structure is distorted tetrahedral, whether it is oxidized or it is reduced, the structure is distorted tetrahedral, and the central atom copper is attached to two histidine using through nitrogen atom present in the histidine, one cysteine through sulfur atom of cysteine, and one methionine through sulfur atom of methionine. So like that also questions can be asked. So which are the amino acids that has been attached to blue copper protein? Plastocyanine. So two histidine, one cysteine, and one methionine. So if you know the structure and all, it will be easy for you to remember the amino acid which is attached to the central metal atom present in each proteins. Now, so the structure is distorted tetrahedral. Now we will learn a little bit about azurin. Azurin is also bacterial blue copper protein. The structure is trigonal bipyramidal. So in this case, the structure is distorted tetrahedral, and in this case, the structure is trigonal bipyramidal. So the central atom is copper. It is attached to two histidine, trigonal bipyramidal. It is attached to histidine. Every time to histidine means it will be attached through nitrogen atom. Okay. And it is attached to one glutamine. To glutamine, it will be attached to through oxygen. And one cysteine, meaning it will be attached through sulfur, and one methionine. Methionine also it will be attached through sulfur. So these are the amino acids that has been attached to azurin. This also acts as electron transfer, mediates electron transfer between enzymes, and each azurin monomer is 14 kilodalton weak. Okay, these are regarding azurin. I just told about azurin because it is also a blue copper protein. So it might help you, because when some questions comes regarding azurin related to plastocyanine, this can be compared and asked what are the geometries of plastocyanine and azurin. So plastocyanine is distorted tetrahedral, whereas azurin is trigonal bipyramidal. And what are the amino acids attached? In this case, it is one cysteine, one methionine, two histidine. Here also one cysteine, one methionine is present. Two histidines are also present. One extra is one glutamine. Okay. Now the question was the coordination geometries around the copper ion of plastocyanine, a blue copper protein, in oxidized and reduced form respectively are distorted tetrahedral for both that we saw earlier. So I will just tell you once again what are the things we learned today, so that it will be easy. We learned about amino acids. So there are 20 amino acids, and all the three groups COOH, NH2, H are same. Only the R group is different, and based on R group we get 20 different amino acids like glycine, alanine, valine, leucine, isoleucine, etc. So we should know the structure of amino acids so that we can answer any type of questions that is asked as shown here today. The next one we learned is about hemerythrin, which is used for oxygen transport. The important thing about hemerythrin is that it has two ion centers. Okay, two ion centers. It does not have any heme group, but has two ion centers. It also have a deoxy state and oxy state. In deoxy state, it will be the both ion centers will be in Fe2 plus oxidation state, whereas in oxyhemerythrin, both ion centers will be Fe3 plus oxidation state. And deoxy state is colorless, whereas oxy state is red-violet in color. And the oxygen is attached here as HO2 minus via a hydrogen bonding will be present here. And the coordination is important. In deoxy state, one ion is pentacoordinated and the other ion is hexacoordinated, whereas in oxy state, both the ions are hexacoordinated. Hemerythrin. Okay. The next one we learned about chlorophyll. The ring system is chlorine ring system. Central atom is magnesium, present in +2 oxidation state. So chlorophyll is present inside chloroplast, which is used in which is helpful for photosynthesis in plants, etc. And whichever is capable of doing photosynthesis are called as photoautotrophs. Okay, photoautotrophs. So this photosynthesis can be classified into two portions, one light reaction and the next one is dark reaction. In light reaction happens in grana and dark reaction happens in stroma. And in light reaction, oxygen molecules are formed, and in dark reaction, carbon dioxide is converted into carbohydrates. So these are the things that we learned regarding chlorophyll. And next, lastly, we learned about plastocyanin and azurin. So plastocyanin is a blue copper protein. Azurin is also a blue copper protein. Both contain copper. And in plastocyanin, this copper is attached to two histidine, one cysteine and methionine, whereas in azurin, it is attached to same two histidine, one methionine, one cysteine, and extra one glutamine. Therefore, the structure of plastocyanin is distorted tetrahedral, whereas azurin is trigonal bipyramidal geometry. Okay, this much we learned today. So, is it clear?
Yes, ma'am.
Okay. So I have given reference for each questions. You can go and visit the classes in NPTL. That will help you in order to know further. But these are mostly related to the questions that has been asked and that can be asked in the future. Okay. Now,
Hello,
anybody?
ma'am.
Hello?
Ma'am, azurin is also having +1 and +2 oxidation state, no, ma'am?
Yes. It also is similar to plastocyanin because both is uh, acting as electron transfer agent. No, so electron transfer agent means it should act as an oxidizing agent. Oxidized state it should have as well as reduced state it should have. So copper 1 and copper 2 it has same like plastocyanin. Okay.
Yes, ma'am.
Okay, fine. So I will give you my mail ID. If somebody has any question, you can ask 19chph14 at uohyd.ac.in. Okay, and mostly in next class I will be dealing with isomerism, tolerance reagent and all. So the question, this is the question that I will be already it is going to be 8 o'clock, so I will just tell you the question. The complexes COH2O4Cl2NO2 and COH2O4ClNO2Cl are given. So this is the question. We have to know what are isomers. For this we learned in coordination, we learned how to name, right, in one class. In next class we will learn about different isomers, stereoisomers and structural isomers. In that, under that it comes linkage, positional ionization. We will learn about each isomers in the next class so that you will be able to answer any such questions. And also we will learn about R and S configuration mostly, and tolerance test, because I have seen in one question, in one paper itself they have been asked tolerance test, Benedict's test, and in 2-3 papers they have asked regarding tolerance test. So that also we will be discussing in the next class so that it will be useful for you if in next class any questions has been next exam, if any question has been asked regarding this chapters, this test and all, it will be easy for you. So we will be learning about that in the next class. Okay. I hope the class
Okay,
was
ma'am.
clear.
Thank you.
Okay, fine then.
Thank you, ma'am.
Thank you. Bye. Have a good
Bye bye,
night.
ma'am.
Bye.